Welcome to the acid and base problem. As you can see, we have question 7 there. You're required to define strong acid and then also to calculate HX solution. You can pause and go through the problem, as I'll be moving fast not to consume more space, data and time. Okay, so pause and go through the problem and see if you can answer on your own, and then you can follow along on this video. Application of ratio should be considered. So any balance, the purpose of chemical equation is for you to balance. So balancing should be, so the equation itself should be balanced, and you're going to use the ratio to determine other values. So volume correct SI unit, that one is a prerequisite. Application of common sense, balance question, and then data collection is skills. I think there's an error there, it's not still skills. And then you have monoprotic and then polyprotic acids. The difference there is the number of the hydrogen on the formula. And then also you have to define strong acid. We go back there, as I can say, I mentioned conjugated base, cross multiplication and so forth. And then now we have to acid. Strong acid is an acid that ionizes completely in water. So that's it ionizes completely in water, and we get you 2 marks there. Then you have to calculate 71.2. It says calculate the concentration of the hydrogen ions in HX. So we are given the equation. So when given the equation there, then we follow along with the equation. So the equation, you can, I think it's in the formula sheet, but you better remember it in your head, because when it's in your head, it's much easier for you to apply it. So pH is minus log, and then concentration of the hydrogen ion. So that is the equation. So pH means potential of hydrogen, or hydrogen potential, and that's equation. The second step will be substituting. As you can see that we have to substitute values. Then 3 is equals to minus log concentration of hydrogen ion, and then that gives us our second step. The third step would be we should apply, you can use minus log concentration, then you punch on your calculator, but I prefer doing it manually. So you put the base 10, the log has a base 10, and then that's equation 1, equation 2, and then where we substitute. So equation 3, here we actually use the log rules, whereby the log has a base of 10, and then the next step would be we transpose it into from the logarithm to exponent. So that would be 10, that is our base, exponent -3, and then that will be equivalent to the concentration of the hydrogen ion. So is the acid similar in strength to hydrochloric acid? That's once again, because remember, we're given the pH of the hydrochloric acid, or the concentration of hydrochloric acid, and then HX we were given the pH. So the concentration 0.01. so going back there, you can see that's a final back. So you can see from there the hydrochloric acid is 0.01, and the one we calculate is 0.001. So hydrochloric is much stronger in this case. So our answer there will be no. So 0.01 is not equal to 0.001. So the more smaller you get, in this case, like especially in concentration, if the concentration is less, then it's weak. But if the pH is less, it means it's strong, because remember, 0 point something in the pH is a very strong level for acid. So reasons there, I've noticed, I've mentioned a few. So the pH of hydrochloric acid there, as you can see, the pH there of hydrochloric acid is 2, so which means 2 in this case and 3. In terms of pH, the smaller it gets in pH, the stronger it is in acid. The bigger it gets, the weak. So it's not to say it's weak, it becomes more basic. So any number from 6 going down is more acidic, from 6 going up, from 7 going down, more acidic, from 7 going up, more basic. So not the same. So that would be our final conclusion. So let us come to the next question. The next question there, that would be 7.2, sulfurous acid. So 7.2, let us go through the question once again. So in 7.2 you can see we have ampholyte, and then I've defined 7.2.1 what ampholyte is. It's a substance that can react as an acid or a base in a chemical reaction. So we're going 7.2.2, whereby we have sulfurous acid. Okay, it's sulfurous acid, and then it actually, you can see it moved from H2 to H. So it actually it's actually a base. The base, because remember it's a reversible reaction, so the sulfurous accumulates 1 hydrogen from hydronium to become an H2. Okay, so that is one of the reasons. So ampholyte there would be HSO3. And then also we have hydrogen sulfide. So hydrogen sulfide, that is the one that actually gets extra hydrogen. So when coming to conjugates things, it's a difference of 1 hydrogen only. So you can see that it has from hydrogen sulfide to sulfurous acid. So that is that we have 2 hydrogen there and you have 1 hydrogen there. So that gives you the conjugate equivalence. Alright, so that gives you the base. And now we go to question 7.3. We're given the volume there, so we're going to say, okay, volume is 100 mil, and then remember we as SI unit must convert that to the equivalent of a liter. Okay, so what we'll do is that we divide by 1,000, because 1,000 mil makes 1 liter, so that gives us 0.1 liter. So a liter is equivalent to decimeter cubed, so it's also 0.1 decimeter cubed. So we have the correct unit there. Every effort you make to convert something from non-relevancy to something relevant, you get awarded. So our next step will be we get the equation. So the equation there will be number of moles over volume, and then we substitute that. Our concentration there is 0.2, we write 0.2 there, and then our volume, number of moles, that's what we are solving. And then what is number of moles over volume? Volume is 0.1, and then cross multiplying that will give us our answer that we need. So it's 0.1 times 0.2. So that is it. So multiplying that gives us 0.02. So that is our final answer. So those are the number of moles. Okay, so this number of moles actually that's what my number of moles are according to the information given. And then our next step is that the excess acid neutralizes another solution. So you should go back to the ratio. You can see that it's 1 for 1. It's 1 1. So you can use the ratio on the balance equation. So this one is forward reaction only, it cannot be reversed. Okay, so now what we do is the big question. We have to calculate the mass of impurity. So what this means, it means that by impurity means those are things that are not what we think it is. Like in this case, sodium carbonate. So sodium carbonate had some other things attached to it. So only sodium carbonate will react, you know. So the axis of the acid, let's see what happens to it. Once again, given volume there, 20 centimeter cubed, we divide by 1000 to give us decimeter cubed. So that's exactly what we are going to do. So 20 divided by 1000 gives us 0.02 decimeter cubed. And then from there, what we do now, we actually see what volume is this one. This is volume of magnesium hydroxide. Okay, magnesium hydroxide. Okay, so we can now detect that, okay, the concentration there, what would be the concentration, so that we also have to calculate the number of moles. So 0.02, that's our calculation. Once again, our number of moles, we need to detect that, and then we have our volume there, 0.02, so we have to cross multiply. Cross multiplying that gives us the answer that we need, the number of moles. So that over 1, you cross multiply, then n is equals to 0.02 multiplied by 0.02. So that gives us 0.004. All right, so that's our number of moles. So that's the number of moles that reacted. That is the acidic part. So that is one that reacted. Remember, there's two reactions. The first one, all reacted, and there was extra acid that went to react with magnesium hydroxide, and then from there we found that, okay, that was the excess. Then from there we have to also detect that, okay, since the number of moles is 1 to 1, we can also detect that that was the number of moles for magnesium hydroxide, which can also be translated to be the number of moles of the acidic. So once again, we rely on the ratio 1 to 1, you know. So that's 1 to 1, the sulfuric acid, magnesium hydroxide, magnesium sulfate, water, 1 1 1. So we check that ratio again is 1 to 1, and then 1 to 1 in this case. So our ratio there will be 1 to 1. Then that means that that will also be 0.004. Okay, the number of moles of what? Of acid that reacted. So remember our answer there, we have to calculate carbonate, sodium carbonate. So we will rely on the ratio once again, that sodium carbonate with sulfuric acid, the ratio is 1 to 1. So which means 1 mole of sulfuric acid reacts with 1 mole of sodium carbonate. So that is, so we're looking, that was the excess part. All right, that is our excess information, and then we need to know exactly that, okay, what was the number of moles that actually reacted. We need to know the previous one, because remember, we were given the previous value. So number of moles of acid that actually reacted. So that's what we need to find out. That, okay, so we have sulfuric acid, sodium carbonate, and then that would be you need, that's 0.2 minus 0.004. So that means, remember, so we need to know what is the value that actually reacted before we had the excess. So those are values. So it's going to give us 0.16 to not be mistaken. So number of moles. So these are moles of acid that reacted. So 0.016, and that will exactly be number of moles that sodium carbonate, because we still stick to the equation. So that is sulfuric acid, the number of moles for sulfuric acid. So that would be sulfuric acid versus sodium carbonate. So we have to write sodium carbonate on the other side, so that we're going to compare the ratios of the two. So comparing that, we can see that, okay, the ratio there is 1 to 1. So in chemistry we rely a lot on ratios, so 1 to 1, so it means the sodium carbonate there will be 0, that would be 0.016. So with that information in hand, we need to know, let's say they want the mass, if I'm not mistaken. So getting to the mass, we'll need to find the molar mass of sodium carbonate. So after we have found that, we need to find the molar mass. We are converting that to mass. So we're going to check for sodium. Sodium there is 23 gram per mole. So that's sodium there. So the 23 there. So that's 23. So that would be 2 multiplied by 23. So that's what we're going to do. Plus, so we check the mass for carbon. So there's carbon there is 12. So we go back there and then we apply 12. And then plus, we get the subscript becomes the multiply. Again, it's 3 times 16, because oxygen is 16. And then we have 2 times for the 23 is for the 6. We have 12 plus that would be, I think, 48. Then adding that together gives us 106 gram. That is gram per mole. So for 1 mole of sodium carbonate, you have 106 gram. So number of moles is mass over the molar mass. The mass means the mass of what you have compared with the molar mass. So that's when you're going to know how many moles are there, considering that all atoms are more or less the same when they break up. Using Avogadro. So we have 0.016. That's then molar mass. Our molar mass is 106. And then finding molar mass, you have to cross multiply. So molar mass will be 0.016 multiplied by 106. Okay, that gives us, punch in your calculator, it should give us 1.696 gram. So that's it. The other thing that we're going to look at, that is pure. So of pure sodium carbonate. But we're not done with the entire equation, because remember the equation says we need to find the impurity. So that's purity. So we need to have another equation again that will give us the impurity. So we just use common sense there. Once again, remember what is one of the kinds. So we have 5 gram of impure sample of sodium carbonate, and then we need to subtract from the 5 gram. So we write simple equation, and the equation will be purity. Okay, so pure plus impure, okay, gives us pure plus impurity gives us 5 gram in this case. So that's everything. So we need impurity. So we already have pure there, then we just have to substitute, that is to calculate the impurity. Then we have the pure is 1.696 gram plus impurity to give us 5 gram. So making impurity as subject of the formula, we have 5 gram minus 1.696 gram, and then that gives us should be 3 point something. It's 3.3. You just punch that in a calculator. 3.304 gram of impurity. Yeah, so that takes us to our final answer. So you can go over. We're just gonna number the steps. Step 1, you have to find the volume that participated. And then step 2, we're supposed to find number of moles. Step 3, we use the ratio to compare the ratio. And then in step 4, we find moles of acid that reacted from the excess went to apart from the excess. Step 5, molar mass of sodium carbonate. And then 6, we find the number of moles. And then step 7, then we find the number of impurity mass. And then step 8, we use the equation to find our impurity. And step 9 is our final answer. You can go over again. You can always pause and go through the problem. And yeah, as always, when we're done with this, we actually have an activity. So you just say recap on that. Sodium carbonate, going back, checking. So you always go answer, check your answer with the question, answer question. You go back, find out what question, and did you understand the question completely? Is there any way you might have made human error and things like that? That is if you have time. That's why you need to study. In exam, we really don't have time to go all over our previous steps. We just keep answering and hope we never made any human error. Yeah, so don't forget to subscribe. Now we have here equation, that's question 7. So you can go through the equation there. You can go through the equation. The equation that actually requires that you solve again monoprotic acid HY. You just go through the it's more similar to what we did. So the acid, the brown state lorry. We have arrhenius and brown state lorry. Definition of acid for grade 12. No both, because they'll tell you they want arrhenius this year, next year maybe brown state lorry, and so forth. And then the third one is Lewis. You learn that in university. And then you go through the question and the line, everything. So you're given them concentration. And then you have to solve for sodium carbonate, equation of hydrolysis. Conjugate acid once again, and then giving other further questions. So there's a lot of marks, like trying to calculate the concentration of hydrochloric acid. So when they ask you about hydrochloric acid, they give you more of sodium carbonate. So good luck on your homework. If you guys get stuck, don't forget to either email me